Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Dutch Flatmates Boundary Sums by Flinty and Palpot. And here are the rules. We have normal chaos construction rules apply, where each row, column, and to be determined 9-cell region contains the digits 1 through 9 exactly once each. And for these 9-cell regions, they must be orthogonally connected. Now, what does it mean to be orthogonally connected? It means you can go from any cell in the orthogonally connected region to any other cell in that region just by going through edges, all while staying within the region. So, for example, to get from here to here, you can go from this path, going along edges, all while staying within the region. Here is an example of an invalid orthogonally connected region, because even though these two cells can get to each other by going through edges while staying within the region, they can't get to the other cells in the region just by going through edges. They have, while staying within the region, they have to go through a corner, or they have to go through an edge and exit the region, which is not allowed. So that's an example of how chaos construction rules work. We have Dutch flatmates, where every 5 in the grid must have a 1 directly above it or a 9 directly below it. It may have both, but it doesn't need both. So, for example, if we had a 5 here, as long as it would be valid as long as we had a 1 here or a 9 here. That's all that works. And that's an example of how Dutch flatmates work. We finally have boundary sums, where clues outside of the grid give the sum of the digits that appear in the first group of cells seen from that direction in that row or column ending at the first region boundary. So that would mean the first X number of digits must add up to 5, where you have a region boundary coming at the end of that sum of digits. So obviously you could have, for example, a 5 here, or you could have something like 1, 4 would be valid, and then you have a region boundary, right? So it's basically the boundary sums are the sum of all the digits up until you see the first region boundary. Between regions, not including the region, not including the boundary that surrounds the entire grid. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's draw a boundary across the entire, around the edge of the grid. So these add up to 5 for these sets. Now, you cannot have more than 3 digits. You can't have more than 2 digits ever adding up to 5 for the region boundary. And every 5 needs a 1 above it or a 9 directly below it. Well, these digits are never these have to be from 1 through 5 here, which means the remaining digits here have to be 6 through 9. Well, where can 5 be in column 1 then? 5 can't be here because there's no way it has there's nothing above it, and it can't have a 9 below it. 5 could be any of these as long as it has the 1 above it. But that means this can't be a 5 by itself. This has to add up to 13, so this has to be a 6-7 pair. which forces this to be an 8-9 pair here. So this is then a boundary here, because this sees 13. These must be the same region, because to add up to 27, you could have 4 or more digits. You have to have at least 4 digits, I should say. These add up to at least 16, so it's at least 2 digits. And how these two must be the same region. And then it ends there. So this must be all light here, at least, because it's at least 3 digits worth. Well, how does this work? Can you have a 5 here? That means it stops at that boundary, so then it would have to go down here, and then this would have to be 5 adding up to the region border. But we know this is necessarily part of that region. So, and this has to be 1 through 5 also. So this cannot be 5 here, because if we try to have a 5 here, then this would be not part of its region. So 1 cannot be here, so this can't be 4. This must be 2 digits adding up to 5. And this is 1 through 4 here. That means this can't be 1 through 4 here. Now, the problem is this has to be 5 through 9 here, right? Which means this is definitely a boundary here, because this can't be part of this region. We already have 1 through 4 here, and if this were part of that region, it would be greater than 5 for that sum. So this must be boundary here, and this must be a 5. Well, this 5 can't have a 9 below it, so this must have a 1 above it. So this must be 1 and 4, which means this can't be 4 and 1. It's 2, 3 as a pair. There's no 2, 3 available there. If this were to try to add up to 5 with 2 digits below, there it would have to be 1, 4, but then this can't be 1 or 4. So this has to be a 5 by itself, and then it's a boundary, which means it must have a 9 below it. So this is 9. This can't be 5 here. These can't be 1. So these must add up to 5, these must add up to 5, and they are all part of this region. Well, not necessarily. This is definitely part of that region, and this could be a separate region. We know there's a boundary here, so there's a boundary there. There's definitely a boundary there. Okay, so since there's a boundary here, this must be part of that same region. So we know this is green, and this must be 1 with 2 or 3 here. It has to extend here. We don't know where, though. This adds up to 15. So it could be 2, 4, 9. Or 3, 4, 8 adding up to 15. We know that we have a 1, 2, 3 triplet in column 2, which eliminates 1, 2, 3 in the rest of the column. So this must be 5 through 9 remaining here. Okay, this can't be 6 or 7 because of 6 or 7 in the region. This must be greater than 3 digits. If we try to have it as 2 digits, it would only be 7 and 9, but we already have a 7 in that region. So this must go up to here, at least. Oh, this is a boundary because that's 1 and 4. and then its boundary. So this is a separate region, so this has to go here. So I guess we'll make that pink. This is boundary here. Medium has to continue out that way. So this sees 20, so then it has to go that way. Pink then has to go that way. Light has to go that way because they're not full yet. Okay. 20 is at minimum 3 unique digits summing up. This is 3 digits. This is 2 at least. This has to be, could be 1. So this has to be at least 3 digits that way. That means this must be at least 2, or it's part of the region. Because 2 digits can add up to 14. Could be more than that, though. Okay, so we have 1, 2, 3, 4, 5, 6, 7. You could have 8 and 9 there. That is possible. Remaining digits in row 1. We have 1, 4, 6, 7, 8, 9. This can't be 9, though, because it's a sum of 8. This is 1, 2, or 3 here. To add up to 3. This is 1 through 7. Because it adds up to 7 until the first boundary. Pink has to continue out here because there's no other place for it. Light has to continue out there because there's no other place for that. 1, 2, 3, 4, 5, 6, 7, 8. And it could go 9 here or 9 here. If we try to go 9 here, we would have 7 digits, 7 cells trying to be 7 cells available. Therefore, it can't form a full region by itself. So if we go light here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 cells trying to fit in 2 regions, which doesn't work. So light has to go that way. Therefore, this goes that way, and pink has to go out there. So we know this adds up to 20 without a 1, because you only have 3 at most here. So you have 3 through 9 here. This can't be 4 or 9 because of 4 or 9 in the row. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's done as a region there. Okay. Remaining digits of the light region. This cannot be 5 or 9. We still need a 5 and 9. And this can't be 5 here, so that must be 9 here. Which makes this 5 here, and this is 6, 7, 8, which means the remaining digits in the column are 1 through 4. Because of that, green can never go out this way, because it already has all the 1 through 4 allowed. This can't be red. If we try to have a different region here, it doesn't work because green cannot go that way, so it would have to take up all of these. There's no 9 here. So these both must be green. This must, well, we don't know. It can't go out this way. So it could be 1, 2, or 1, 2, possibly. Either way, this is green. So this cannot be 5 or 8. It's 6 or 7. And one of these is green. This cannot be a full 4, because then you have the same problem, right? then you, well, not a similar problem. You would have 1, 2, 3, 4, 5, 6, 7, 8 digits accounted for here, 8 digits accounted for here, and then 5 digits, 5 cells, which only 2 can be taken in by the green and the red region, but the other 3 are blocked from connecting with other cells. So this must go that way. This adds up to 16 without 5, 6, and 7 available. Um, hmm. Well, you can't have 8 and 9 there. But you have to have 1 out of 8 or 9 there. These can't be 5 to add up to 20 because we know we already have a 5 in that region. Without 5, 6, and 7. So you could have 3, 4, 8. Or, no, wait, 16. 3, 4, it has to be 3, 4, 9. So this must be a 3, 4, 9 triplet, which eliminates 3, 4, 9 in the rest of the column and in the rest of the region. So no 3, 4. Can this be part of red? Yes, it could be. If it's 2, 5, that's 1, and that's 8. So that's possible. So either way, this is not going to be 4 digits adding up to 7 here. So this is, or sorry, 3 digits adding up to 7 here. So this is a boundary. Well, it doesn't, we could have a separate region and then it goes there. That is possible. So we don't know if there's a boundary. Remaining digits of column 4. We have 1, 2, 6, 7, 8. Okay, that seems fine. This has to be a region. We have 8 here already. This is boundary, definitely. 8. We have 1, 2, 3, 4, 5, 6, 7. If we try going here, then only one of these can be green, and this would not have a... I guess it could be both of them. We do know that these two cells can't go that way. So if we try going that way, again, one of these could be part of green, but the other one would not be. So this has to be its own separate region. Can it be 1, 2, 3, 4, 5, 6, 7, 8, 9? It could. We'll mark that as dark for now. Dark has to get out. Right, this could be two. Oh. One of these has to be a dark. So this actually cannot be part of pink. 1, 2, 3, 4, 5, 6, 7, 8, 9. If we tried that, we have one that could be part of green. We don't have any that can be part of pink, and we can only have 2 more that are part of red. This cannot add up to 27 with a 1 or 2 there. So this must be 5 digits to add up to 27, right? 4 digits adding up to 27 is at minimum 3, 7, 8, 9. So this must be part of it. Therefore, this is part of the region. And it has to be 2 and 5 adding up to 7. Which means this can't be 2, it's 1. This can't be 5, it's 8. Um, hmm. 1 eliminates 1 in the rest of the column. 8 eliminates 8 in the rest of the column. So we have to have 2, 3, 4 be part of this region here. So this is not 2. I guess we'll make this yellow. Yellow has to go out. This adds up to 27. This adds up to 9. So this is definitely part of its own region, and it's at least 3 in length. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore, this has to be part of another region here. Interesting. This adds up to 27. Can it be 3 or 4 here? At most, this would be 1 and 8, 9. So these 3 must add up to 18. And so the answer is no, because that would be 4, 5, and 7 at minimum, which only adds up to 16. So this has to have a 9 here. That means this can't be 9 here. This adds up to 18, so these 2 digits must add up to 9, which is 2 and 7, which makes that 6 and 5. Remaining digits in row 9. We have 3, 4, 5, 6. So this must be 2 digits here. And then it's a boundary. And this must be yellow, yellow at least, because it's 2 digits. And it actually has to be 3 digits here. Because with that, a 6 plus 2 other digits is at least has to have 3 digits to add up to 16. Okay. So we know there's a boundary here. This is blue or yellow. We don't know which. 5 eliminates 5 here. So this is 6, 7 as a pair there. That makes this a 5 there. So this is boundary here. This is boundary there. This is green. Hmm. 3, 6, and 4, 5. Okay. This has to be 1, 6, 7, 8, 9. Because it's part of this region here. I guess I'll make it orange. This is orange or yellow. Huh. Wherever it ends the boundaries here, the remaining digits must add up to 9. It could be 4 and 4, and then this is 9 there, or this is 9 there. This adds up to 20. Huh. So doesn't it have to be 3? It's either 3, 8, 9 or 4, 7, 9. Since 5 can't be here, this can no longer have 6. So 3, 8, 9 or 4, 7, 9. Either way, there has to be a 9 here, which eliminates 9 in the rest of the column. Interesting. So these digits cannot contain 2, 5, or 9. So 1, 3, 4, 6, 7, 8 are possibilities. Okay. It could be going just that way. This is 14. 2 digits adding up to 14. So it's 5, 9, or it's 6, 8. We have an 8, 9 there, and one of these is 8, 9, which eliminates 8 and 9 in the rest of the row. So this has to be not 8, 9. So it's 1 through 7. 6 eliminates 6 here, so that's 7 and 6. This cannot be 6 and 8 adding up to 14, so it's 5 and 9. Therefore, this can't be 4 and 5 adding up to 9. It's 3 and 6. That eliminates 3 and 6 in the rest of the row. This can't be 5 or 6. And 9 eliminates 9 here, so that's 8, which makes this 9. 4 and 5 eliminate 4 and 5 in the rest of the yellow region, so this can't be 4, 5. Okay. Blue, okay, remaining digits of row 8, we have 1, 2, 3, 4, 8, 9. 3 and 9 are no longer part of the blue region. You could have a 9 here. And then you could have 4 in size, 4 in size there. Or even like 5 and then 4 and then 3. That's also possible. So the blue must either go through here, in which case it would have to be both of these because we already have a 3 in the region. Or it goes through here. Either way, this is guaranteed to be blue. No 5, 9, 3, or 6 available, so it's 1, 2, 4, 7, or 8. This can't be 1 because of 1 in the row. These can't be 4. They are in the yellow region. The yellow region needs a 6. Well, it's going to be one of these 4 digits. Oh, 5. Every 5 needs a 1 above it or a 9 below it. This needs a 1 above it, so this is 1. No more 1s here. So this can't be 1 here. 5 needs a 1 above it. One of these is 5, so 1 has to be above it. So this cannot be part of yellow. It has to be part of orange because we know we have a 1 there. That eliminates 1 from these. 5 has to have 9 below it or 1 above it. This 5 has a 1 above it. This 5 needs to have a 1 above it, so that's 1, 4. No 1 there, no 4 there. 5 has 9 below it. 5 cannot have 9 below it, so must have 1 above it. So no 1 here, no 1 here. 5 has 1 above it. 5 has 1 above it. So we have boundary here. Orange needs access to a 9. It cannot get it here. 1, 2, 3, 4, 5, 6, 7. It has to go 8, then 9 there. So this is 9. No 9 here. You could have 5, 7, 8 here. So this has to be orange. This is orange or pink. This could be orange, yellow, or any other thing. 9 cannot be here. One of these is 5. If this is 5, it would have a 9 below it. It could have a 9 below it, I should say. Um, hmm. Um, huh. Yellow has to go to one of these two. Yellow has to go here, at least. If it doesn't, the problem is that it would have only 8 cells available to it if that's the case. So yellow definitely has to go there, so that's a boundary there. This can't be 4 or 5. Okay, no, what are the digits? 1, no 1, because one of these is 1. No 4 or 5. It could be 2, 3, 6, 8. 6, 7, 8, technically. 4 digits. It could be 5 here. Oh, yellow doesn't have access to a 9 if it doesn't go here. One, two, three, four, five, 6, 7, 8, 9, or even 7, 8, 9. It can't go more than 5 digits that way. So if it tries, so this is yellow or orange. If we try to go 5 here, then this doesn't allow a, oh, 9 could be here. Okay, yeah, so 9 could be here. Never mind. Okay. This is boundary here. Pink has to get out, so that has to go there. So the 5 is either here or it's here. You could have 5, 7, 8. No, you can't. So if you try to have 3 digits here adding up to 20, it specifically has to be 5, 7, 8, but then the 5 doesn't have a 1 above it or a 9 below it. So this must be yellow. Which means orange goes over there, so this cannot be pink. And it has to be 6, 7, or 8. So 3 or 4 is here, which means this is also 3 or 4. And then this is, we have a guaranteed 6 here because there's no other place for 6 in column 5, so this can't be 6 here. So that's 4 digits here adding up to 20. You can't have 5 digits here adding up to 16, so then it must go out to here. Because then that would be the full region here of 19, or sorry, that adds up of 9 digits, which only adds up to 36. So this must be a 9 here, and therefore this is 5, that's 9. There's no 9 here. This digits no 4, 1, or 9 here, so it's still the same. 2, 3, 6, 7, 8. So 1 has to be one of these digits here. We don't know which. Hmm. Okay. We have a 5 in one of these 3 cells. And we have a 5 potentially available in one of those 3 cells. Okay. This can't be 1 here. If this were 1, the 5 in the column would not have a 1 above it or a 9 below it. So where is the 1 in row 6? It has to be here. So that's 1. That means this can no longer be 1. How many digits add up to 8 here? It can be 8 by itself, and it can't be 3 digits anymore. So this can't be 4, so it's either 8 by itself or it's 7. It can't be 7, 1. It would have to be 6, 2 if that were the case here. We don't know which way this goes. Remaining digits of row 5. We have 2, 3, 6, 7, 8. Interesting. We need access to a 7 somewhere. So 5 with 1 above it. Can it be over here? If we have 5 and 1, that's 6. 20 minus 6 is 14. It would have to be 6 and 8 here, which is not possible. So 5 can't be here. 5 has to be here. It's 5 and 1 there, which makes that 4 and not 1. So this adds up to 10 here. 16 minus 6 is 10. So we could have not 2 here. So 2 and 8, 3 and 7, 7 and 3. So that means we require this. Where's 6 in the yellow region? It must be here. So that's 6, which eliminates 6 here. That forces this to be a 7, 8 pair, which eliminates 7 and 8 in the rest of the row. So this can't be 7 or 8. It's 3 with 7, adding up to 10. That means this can't be 3 or 7. It's 2, which makes that 8. 2 eliminates 2 here. 3 eliminates 3 here, so this is 2. And 2 and 3 eliminate 2 and 3 here, so that's 4. This 7, 8 pair eliminates 7, 8 in the rest of the region. So that's 6. 4 eliminates 4 here, so that's 3 and 4. This can't be 2, 3 or 4, so it's 2. 4 eliminates 4 here, so that's 3. No 2 or 8 here, it's 4. This is adding up to 3, so we have both of those. No more 2 here, no 4, 9 here. No 3 or 7 here. No 6 or 8 here. Remaining digits, no 4 here. Remaining digits in column 6. We have 1, 3, 5, 7. This can't be 1 because of 1 in the row. No 3 because of the 3, 4, 2, 3 pair in the row. So this can't be 3 either. So that makes this 4. This cannot be 4, 7, 9 anymore. So this must be 3, 8, 9. 3, 8, 9 eliminates 3, 8, 9 in the rest of the column and region. So no 3 here, no 9 here, no 9 here. Where's the 9? It has to be here. That eliminates 9 in the rest of the row. This can't be 8 anymore. It's 7, which means this can't be 7. That's 8. That eliminates 8 in the rest of the row. 1 eliminates 1 here. So we're guaranteed a 2 in the pink region. Okay. 6 eliminates 6 here. And 6 here. Remaining digits of column 7. We have 2, 4, 6, 8, and 9. No 2, 4 here. No 9 here. No 9 here. No 9 here. Where is the 9? No 5 here. Where's the 9 in column 7? It has to be here. So this is 9, which means pink cannot be part of it. So pink has to go up here. 1, 2, 3, 4, 5, 6, 7. So we have boundary here. One of these. So we need access to a 7 and an 8. So it could be both of these. We don't know though. Or it could go here and here, or it could go there, or it could go there. There's many possibilities. 9 needs to be part of the last region, so this is going to be dark. 5 has to have the 1 above it here. 5 could be here. Remaining digits in column 8. We have 2, 3, 4, 6, 7, 8. No 4 here, no 4 here because of 4 in the row. No 2, 3 here because of a 2, 3 pair in the row. Also, that means this is 5 through 8 here. 5 has 9 below it, 5 has 1 above 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 it, 5 has 9 below and 1 above. This is either 2 digits or 1. Can this be pink? No. 1, 2, 3, 4, 5, 6, 7, 8, 9. So where can pink get to? 4, 5, 6, 7. We can go 1, 2, 1, 2, 1. Can't go there because that would close off for the medium gray cells. Blue can get up to here. So this is blue or dark. Dark could go to any of these. Medium can go 1, 2, 3, 4. Cannot go 1, 2, 3, 4. It can go 1, 2, 3 here, right? Or go this way. So medium can get to here. So this is definitely medium because pink can't reach it. Dark can't close it off because then medium would not be able to extend. Well, could it? What about if medium were to go that way? 1, 2, 3, 4, 5, 6, 7, 8. It couldn't close off dark. Yeah, this has to be medium. This, on the other hand, could still be dark. So you could have 1, 2, 3, 4, 5, 6, 7, 8, 9. That is possible. This is definitely medium, though. Where is 4 in column 8? Can't be here, can't be here, can't be any of these, so it must be here. So this is 4. Therefore, this cannot be pink. This has to be dark here then. Does it? Could you go medium going down that way? Hmm. Possibly. Let's not remove that possibility. Pink then. 1, 2, 3, 4, 5, 6, 7. It could be 8, 9, 8, 9, or 8, 9. Any of those are possible. Hmm. Hmm. If we tried going blue, blue here. Okay, one of these is a 3. Guaranteed. Because of that, it cannot be blue and blue here. So if it's blue, it has to go either blue here, then blue here. Or blue, blue here. Or blue, blue here. Okay. Mm, 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 mm. Remaining digits of column 9 are 1, 3, 5, 6, 7, 8. No 1 here, no 5 here because of digits in a row. Hmm. This is pink, so cannot have a 1. But you could still have a 5 there because a 9 could be below it. If gray goes here, that would mean it can't have an 8, so it'd have to be 6 and 2. And 4 here, 7, 1. That all works. No 1 here because of 1 in the row. So where is the 1 in column 6? It has to be here. This is 1. This can't be 2 because of the 2, 3 pair in the row. This can't be 1 because of the 1 in the row. So we have a 6, 7, 8 triplet in row 1, which eliminates 6, 7, 8 in the rest of the row. So this can't be 6, 7, 8. It's 4, which means none of these could be 4. Um, hmm. 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 Um. We have a guaranteed 3 here. We have a guaranteed 3 here. That eliminates 3 in the rest of the row. This 3 has to be related to the dark. Hmm. 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 This can no longer be all gray going down to here. Because if we tried to do that, this pink does not extend. So, this cannot be gray. Medium gray. It has to be dark. This can't be dark. It's medium gray. Okay. Hmm. What else can we do here? We need access to an 8 for the pink. And it has to be one of these two. That eliminates 8 from the rest of the column, so this can't be 8. That's 2, which means it cannot be blue. It's dark, which eliminates 2 in the rest of the column here. This is a 6-8 pair. This can't be 5 because of 5 in the row. Where is 1 in row 3? Can't be any of these digits, so it has to be here. So this is 1, which is dark. 5 cannot be here in column 9 because... How did I get that that was 1? I don't remember. Because this couldn't be 1 because of the pink. Right. The 5 in column 9 has to have a 1 above it because it can't be above a 9. So that means 5 has to be there. There's no 5 here, which makes that a 7. This is 7, that's 3, that's 5. Pink needs access to a 5. 7 eliminates 7 here also, so this is 2, 6 as a pair, which eliminates 2, 6 in the rest of the column. So no 6 here, that's 7. So this cannot be medium, it has to be pink. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we're guaranteed to go that way. Medium. It could go this way. So medium has to have a 6 and a 2. If it tries to go this way, the problem is it eliminates all possibilities for that cell there. So it cannot go this way. It must at least go here. So this is not dark. And we don't have access to 3 and 8. So then this has to be medium, medium here, which means this can't be medium here. So this is done as a region, and it has to have 6 and 2 there. This can't be 2 again. No 6 here. 7 eliminates 7 here, so that's 8. Can't be 7 or 8, it's 6. No 6 here. We have 3 eliminates 3 here, so it's 8 and 3. 8 eliminates 8 here, so it's 6 and 8. 6 eliminates 6 here, so it's 2 and 6. 8 eliminates 8 here, so it's 7 and 8. Apologies, I have to take this. I'll be right back. Sorry, I had to take that. That was my mom. Let's continue with this solve. We're almost done. There's no 8s here. We need access to an 8 for the blue. So then these have to be accessing the blue, which means this can't be blue. It's dark. The dark has to go this way. Also, the pink needs an 8, so this can't be pink here. And we should be done with all the regions. Blue doesn't have access to a 3, or cannot make that a 3, so this is, well, also this is 2 and 3. Oh, this adds up to 15, so it's 2, 4, 9, which makes this 3, which makes that 2 and 3. That's 3 in the corner. We celebrate because we're almost done. This must be 8. This must be 7. That makes this as 3. That's 7 here, which leaves this as 6. And does this add up to 21? That's 15 plus 6 is 21. And that's 3. Yeah, I don't know. Maybe Hmm. I felt like this was more difficult than challenging. Obviously not that difficult, but so I don't it's not quite hard level for me, but I usually put things that are in between at one difficulty level higher. Even for a chaos construction, which I've done a ton of, I don't think this was necessarily like straightforward. I think I would place this in hard, even though for me it's between challenging and hard difficulty level. I think it's significant enough above challenging that I would place it as a hard difficulty level. It's not that, I mean, the logic isn't that difficult. It's just that some of the execution could be kind of problematic for people. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.